Hello everyone. So today let's solve the problem number 115, distinct subsequences, right? So let's see what the question states here. We are given the two strings s and t. See here, we have been given the string s. Also, we have been given the string t. So all we have to do is we have to return the number of distinct subsequences of this one s, which equals t. Distinct subsequences of s with equals which equals t actually, right? So see here, we have been given rabbit and we have been given rabbit here. So as shown below, there are three ways we can generate the rabbit from S. See here. So this one, what do we call? We have to generate this one from this one, right? So either we can just go with the first B actually, or we can just go with the, or we can dump the second B, or we can dump the third B, right? So those are the three ways actually. If we dump the first B, it will be RA double BIT. If we dump the second B, then also it will be RA double BIT. So if we dump the third B, then also it will be RA double BIT. Right? The same thing. So there are three ways from which we can make the rabbit within the string S. Right? Yeah. Uh, this is fine. So we have to return the ways actually, right? So the numerical value. This one 3. The output that we got here is 3. This is fine, I believe. Next, we have here BABG, BAG. So we have to see how many ways, in how many ways we can this one get the bag within the string S, right? So there are 5 ways actually. One is so see here, this one we can just remove one this thing, right? So see here, we can just remove this one B B A G, right? So we are left with only B A G. So this is one way, and we can just remove B G B A. B G B A also we can just remove. So we are left with only the first two letters and the last letter BAG. Same goes with these three as well, right? So we can just remove ABGB here. So this will be BAG. So we can just remove AGB here. So this will also, this here starts from the D and it will end at AG, right? Bad. So we can just remove BABG. We are left with only BAG. So this will be, yeah, this will be back. So let me remove this one entirely. Yep. Now let's do one thing. Let's do one thing. Just give me a second here. Just let's discuss the approach. So before hopping into the approach part, let me tell you one thing. So we will be going with a this one dynamic programming to solve this particular problem. So we will be going with a 2D DP basically, but we'll be going with a dynamic programming to solve this particular problem. Yeah. So yeah, let's see the approach. Let's hop into the approach part. So the first step here would be, so we will be considering here. Just give me a second here. M equals S, positive. S has to be always positive, and this one actually N equals T. This one, let me represent this one in this format, right? So we will be building the 2D DP table. DP of size, this one M into 1 into N into 1. So this one M plus 1 into N into N plus 1. Sorry, yeah, this is fine, I believe. Where dp of ij is nothing but the number of ways s of 0 to I minus 1, yeah, forms the t of 0 to j minus 1, this one, for the first j characters, as we are making use of the t2ddp here, right? So what will be the base case here? What will be the base case? An empty t. See here, if the suppose if t is empty, an empty t can be formed from any prefix of s, from any prefix of s, right? An empty t can be formed by any prefix of s, right? So here in exactly one way. So dp of I0 will always be 1 for all I, right? So dp of, so I can just write it in this way, the base case dp of I0, this will be actually always 1. This will be actually always 1. Yeah. So for the non-empty t, non-empty t cannot be formed from the MTS, right? So dp of 0 j greater than 0 will always be 0. So this one I can just write it like this. dp of j, sorry, first we have to represent this one by 0, right? So this one dp of 0 j greater than 0, so this one will be equivalent to the 0, right? So let's move on with the third point here. These 2 points are easy, man. Yeah, this is fine, I believe. Yeah, next the third point here, for each I from 1 to m. So for each I we are considering I, right? I from 1 to m and j from 1 to n, as we are making use of the 2DDP. So if S of I minus 1, the previous one, is equivalent to the T of J minus 1, if S of this one, I minus 1, the previous one, if it is equivalent to the value actually. T of, for the t we are making use of the j, right? So this will be t of j minus 1. We can either use s of I minus 1 to match t of j minus 1, right? So this is one thing. Or we can just skip s of I minus 1, or we can just skip the s of I minus 1, right? Else we must skip s of I minus 1, that is nothing but dp of ij equals dp of I minus 1 j. That also we can do, right? So this is the basic idea. This is the basic idea of with which we will be going actually, right? So we will be considering the let's consider example one, man. Just give me a second. Let's implement the same. We will understand this one even clearly. Yeah. So let's consider the same example here. We have the word R A triple B actually, I and T, R A triple B and I T. So for rabbit, this one we will be going with the R A double B I T. All right. So we have rabbit. So we have what we need to do actually. We have to create this word out of this one, right? Out of this one. So basically for the rabbit, this one RABBIT, repeated choices at the position of an extra b produces three distinct ways, right? So those three distinct ways we have already discussed, right? So the DP adds those counts and returns basically DP of n, sorry, DP of m n, that is equivalent to 3. What does the DP do here? So for the rabbit, RABBIT, repeated choice at the positions of extra B produces three distinct ways. We have already discussed that one. We are not going to discuss that one again. The DP adds these counts and returns DP of Mn, that is equivalent to 3. So the output that we got here is 3, which is equivalent to the output that I have mentioned for the example 1 within the question. So our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of m into n. So the time complexity would lead to big of m into n. We fill in this one m plus 1 into n plus 1 dp table exactly once as discussed in the approach. So the time complexity would lead to big of m into n. So what will be the space complexity here? The space complexity would lead to big of this one. What do we call m into n actually. The space complexity would lead to big of m into n as well, because storing the full 2D DP table of size m plus 1 into n plus 1 will lead to the space complexity big of m into n. Yeah. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of m into n and big of m into n respectively. Now, as we are completely familiar with the approach and the complexities part, let's start writing the code. We are good to write the code. Let's start writing the code. So here the first step, so we have to go with the number of characters in the source string s as well as the target string t, right? So let me assign this one to this one variable m actually. So this will be s dot length and this will be t dot length. Yeah. So this is fine, man. Next, what we will do, as I've said, we'll be making use of the DP. Let's initialize the DP to DDP here. To DDP array, right? So this one will be new int of size as discussed. This will be m plus 1 into n plus 1 respectively, right? So this is fine. Now let's go with the base case, man. Base case is nothing but empty target, nothing but the j when j is equivalent to 0 can be formed from any prefix of s in exactly one way. So this we have already discussed, right? So let's move on with the this one iteration part. So I'll just write it in this way: a for int I equals 0, I less than or equal to m. So this one will be I plus plus. So dp of I 0. Let me assign this one to the 1. Yeah. Now let's do one thing. Let's go with the base case, man. Let's go with the base case. Sorry, we have already went with the base case. So let's fill the DP table row by row, or we can just go with this one column by column as well. We can just fill row by row or column by column, right? So we'll just iterate I from I to m and j from I to n. So that's what we will be doing here. So let's write the two for loops here as usual. So this one will be int I equals 1, I less than or equal to m, I plus plus. So this one is fine for j equals 1, j less than or equal to n, j plus plus. So this is fine. Yeah. Now, if the current characters match, then we can take both the choices. Meaning, so we discussed this one at the end. Let me tell you. We can match S of I minus 1, the previous one, with T of J minus 1 to the dp of I minus 1 into J minus 1. Yeah. So this one we can do. Or we can just skip S of I minus 1 to dp of I minus 1 J. These two things, right? If what if the current characters match? Then only we can take these both choices, right? So let's write the if condition for this. You'll understand this one clear. So this one will be if s dot char at. So this one will be I minus 1. So this is fine. I minus 1. If it is equal to t dot char at. So this is fine. So this one will be j minus 1. Then what we will do? Let me go with dp of ij equivalent to dp of I minus 1 into j minus 1. Yeah, again. So this one will be dp of I minus 1 into j. dp of I minus 1 into j. Right. So else what we will do? Else what we're gonna do? So if they don't match, the only option is to skip s of I minus 1 as per the discussion. So this one has to be dp of ij equals dp of I minus 1. Yeah, so we are almost done with the code. Only thing that we are left with here is we have to return the answer. Answer is nothing but the number of ways, this one, a number of ways, full S, nothing but the M forms full T, nothing but the N actually, row and column, right? So this one I can just uh, write here dp of M and N actually. Yeah, this is fine. So let me format the code and let me hit the run button. I hope this works for all the test cases. Let's see. What? Index 7. So what I have written here, if this is fine. S dot caret I have written. So this has to work. So I minus 1 we are considering. This is correct actually. If it is equivalent to T dot caret, so this one is also fine. Uh, J minus 1, so this is also fine. Then what is wrong here? Just give me a second here. So what mistake I've done here is, see in the line number 12 actually I have written j equals 1, j less than or equal to n. Instead of j plus plus incrementing the j, I have incremented the I. So that was the mistake actually. Let me run the code now. This has to work. Let's see. There are any types. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly. So I hope this works for all the test cases. Yeah, we can clearly see here, right? All the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.